So now we will be taking the derivative of arc cosecant of x or cosecant inverse of x, whichever it is that you prefer, using a method called implicit differentiation. So as we did in the previous videos, we will take advantage of the fact that the cosecant and the arc cosecant are inverses of each other. That way we can isolate for x. So first thing we'll do is we will take our function and set it equal to y. Since our function y is equal to arc cosecant of x, Arccsc of x. So what we'll do is we will take the cosecant of both sides in order to isolate for x. So cosecant of y is equal to the cosecant of the arc cosecant of x. Now the cosecant and the arc cosecant are going to cancel each other out here. All we'll have left on this side is x. So cosecant of y is equal to x. And this is a statement that we'll be using later on in the video in order to finalize our answer and put everything back in terms of x. So essentially what we'll do now is we will take the derivative of both sides of the equation. So d by dx of cosecant of y is equal to d by dx of x. And we have a y function trapped within a cosecant of x function here, so we will be using the chain rule in order to differentiate this. So our f, which is our outer function, g, inner function, f prime, and g prime are just the derivatives of the outer and inner function. So our outer function is cosecant of x. Our inner function is y. Our f prime of x is the derivative of cosecant of x, which is negative cosecant of x, cotangent of x. And our derivative of y is equal to dy by dx, which is essentially what we're solving for in the end. So we want to take the derivative of this. So what we'll do is we will substitute in y wherever it is that we see x in our f prime, since chain rule essentially asks you to plug in g wherever it is that you see x in your f prime. It's f prime composed of g of x times g prime. So what we'll do is we will substitute in y wherever it is that we see x here, which is negative cosecant of y times cotangent of y, and then multiply that entire expression by our g prime, which is dy by dx. Now let's go ahead and clean up this side. Cosecant of y will be equal to, and rewrite the fact that cosecant of y is equal to x, because we will need that. So we have this derivative is equal to the derivative of x on the other side of the equation. So we have negative cosecant of y cotangent of y times dy by dx is equal to the derivative of x on the other side. I had erased it, I'm sorry for that. But essentially on this side all we had was an x and we needed to differentiate that. Derivative of x is 1. And we want to isolate dy by dx, so we will divide both sides by negative cosecant of y times the cotangent of y. Same thing over here. This cancels this. All we will be left with is dy by dx is equal to negative 1 divided by cosecant of y times cotangent of y. So now, what we can do is take advantage of the statement that we had found a little bit earlier, where cosecant of y is equal to x. So let's go ahead and construct a little triangle with an angle y down in the corner. Now the cosecant is going to be the inverse of the sine, and sine is the opposite divided by the hypotenuse. So the cosecant of y is going to be the inverse of that, where it is that it will be the hypotenuse divided by the opposite. So x over 1 is going to be equal to hypotenuse over opposite. So we have x, and then we have 1 over here. This bottom corner will be, using the Pythagorean theorem, x squared minus 1. And this managed to get erased somehow. All we're going to do now is solve for cotangent of y, since we already know what cosecant of y is. So the cotangent of y is going to be equal to the inverse of the tangent of y. Tangent of y is going to be 1 over the square root of x squared minus 1, so the cotangent is essentially when they are going to be flipped. So the cotangent of y is equal to the square root of x squared minus 1 divided by 1, which doesn't really change anything, so realistically it's just the square root of x squared minus 1. So what we can do is substitute both of these statements in order to put things back in terms of x. So dy by dx is going to be equal to negative 1 divided by cosecant of y is equal to just x, and then cotangent of y is just equal to the square root of x squared minus 1. And that is our final derivative using implicit differentiation.